Okay, this video is to introduce natural logs. So in order to talk about natural logs, we have to talk about the number e. E is the number 2.718281828, etc. It goes on forever. It's another irrational number. It's an irrational number just like pi. It goes on and on and on forever without ending. Yeah, and this one happened to be named by Euler, so he gave it the letter of his last name, E. Now, where this number comes from is the compound interest formula, actually. It probably goes something like this. The bankers were sitting around going, how can we get the most money out of this formula if how much people invest? So what if somebody were to take this formula and invest $1 for 1 year with an interest rate of 1, okay? And so all the numbers in here are 1, except for the number of n, the number of times it's compounded. So they're like trying to be greedy and compound it as much as they can, all right, increasing in as much and much as much and much and much. And how much money will that person have over the course of just 1 year? And the answer would be that $1 could become $2.72. So as increases to infinity in this formula, this approaches the number, becomes the number e. So that's interesting. This number e, because it's used in banking like that, became really important. And so we started talking about the function y equals e to the x. All right. So the inverse of y equals e to the x is y equals ln to the x, and that is where this is coming from. This is a natural log. What this is an abbreviation of log to the base e. So instead of being to the power of 10 like normal or to any other number, we're using the base of e. And whenever we have the base of e, that is abbreviated like this. It's a natural log. So this means the same thing as this. Alright, so let's look at some of these. Both ln and e are buttons on your calculator, and that's the main thing that you're going to be doing with this on your paper, really, is just calculating what the natural log and what e to certain values are on your calculator. So we'll talk about that in class. But all of the previous laws that we've learned about logs apply to natural logs. So you're going to be able to do the exact same things. Just make a note, the natural log and this value e here, they cancel out. They're inverses of each other. So let's look at this first one here. One of the rules that we learned was that when we have a 3 multiplied in front, it can become an exponent. So I'm going to take this 3 and I'm going to rewrite it as 2 to the third. 2 to the third is 8. Now, e to the ln, these cancel out in the same fashion as log canceled out before. E and ln cancel out, and so the only thing that's left is 2 to the third, which is 8. Okay, so in this one, the same rules apply. When you have an exponent out front with this e, like squared right here, we have 3 times ln of e squared. That squared can come out front to become multiplication. So I'm going to take this 2 and I'm going to move it out front. 2 times 3 ln e. 2 times 3 is 6. But the ln and e, again, they cancel. These cancel out. So that's what I want you to pick up from this. ln and e cancel here, just like ln and e cancel here. Alright, and how about this one? We haven't done anything like this yet. Here's how I'm going to solve this one. I want you to get in this mindset as well. You can take the natural log of both sides. So I'm going to take the natural log of both sides here, ln of ex equals ln 59. So I'm going to put the natural log in front of both sides. And how that helps me is I have ln and e. They cancel out. Now I just have x on this side. And the natural log of 59 The natural log of 59 I can put in my calculator. And it is 4.0775. So, it's helpful to know that these cancel out. Let's try a little harder one. Okay, so now I have the natural log of 5, negative 5x, and the natural log of 4 minus 3x. Well, I have a log on both sides of the whole side. So the same thing as before with my logs. They cancel out. They're the same on both sides. So what I have left is just the parts that were on the inside here. So now I can easily solve for x by adding 3x to the other side and dividing by 2. Dividing by negative 2, which gives us negative 2 for the answer. Okay, on this one, I've got this negative 8 in front. Let's change that coefficient to be an exponent. So I'm going to take this coefficient and move it up. So now I've got ln at negative 9x to the power of negative 8 equals negative 8. Okay, I'm thinking of two different ways I could really do this from here. I could think about it. I could raise each side to the e power and put an e here and an e here to make ln cancel out, but how I was doing these before was, once I had my log, I'm rewriting my log in exponential form. So I'm actually going to rewrite this natural log as a log so I can see better what I have. Natural log is the same as log base e. So thinking of it as a log instead of a natural log, these are the same thing. Natural log is just a log base e. Now I can take my log and rewrite it as an exponential. So as an exponential equation, I would have this e to the power of this negative 8 equals this negative 9x to the negative 8. Okay, so both sides are raised to the power of negative 8. So that means that it looks like what I really have is that e equals negative 9x, which means that my answer, dividing by negative 9, is negative e over 9 equals x.